Hello, I'm Ricard Vilalta, Senior Researcher at CTC, and today I will be presenting the multi-layer transport network slicing with hard and soft isolation. I would like to thank my colleagues from Telefónica, OAM, and Volta Networks for this paper. So let's start with the provisioning of connectivity services that basically guarantee a specific set of service level objectives. Regarding network resources is expected to benefit many use cases such as beyond 5G networks or NFV and data center interconnects. On top of this, we have transport network slices that provide this connectivity coupled with a set of specific network resources, which are committed between several endpoints over a shared network infrastructure. Each transport network slice is associated with a tenant. Each tenant can then control and manage all its slices. The motivation for this paper is related that as underlying resource multi-tenancy is supported, multiple isolation options are provided, such as soft slicing or hard slicing. The idea of this paper is to present an end-to-end architecture that provides transport network slices deployed over multi-layer IP over DWDM networks, and we're able to offer several degrees of isolation, from a hard slice to a soft slice, which might be required and implemented for the requested transport network slice. So I like to say that network isolation can be understood as a continuum. It's not that we have only soft slice or hard slice, but we can see in this graphic that it can go from a complete isolated system, like that's a hard slice, up to a non-isolated system, which is a soft slice. We understand soft isolation when we focus on QoS mechanisms that provide dynamic allocation of the available network resources. An example of a soft network slice allocation is, for example, a VLAN assigned to a customer to carry voice data traffic, usually transported by layer 3 or layer 2 VPNs. A hard isolation is something different. Hard isolation provides component virtualization and replication. An example of a hard network slice is where we have routers under the same administrative domain, and several services are configured between these routers. So we provide complete differentiation of the resources per tenant. So in this graphic, you can observe the proposed network architecture. We present a network slice controller, which is able to provide the RESTconf API for network slices, for requesting network slices with different degrees of isolation. We will later take a look at this, but you will see that we are proposing an IETF draft for network slices. Then below, we have an end-to-end lifecycle management for this transport network slice, and we coordinate with two other controllers. We have the IP SDN domain controller and the optical SDN domain controller. You can observe that in this case, we are using netconf protocol and gRPC protocol for the creation of these virtual router instances, and then we use netconf protocol for managing these virtual routers. On the other side, we have the ONF Transport API, which allows us to provide optical network interconnection at the optical layer. So in this figure, you observe that we have a DWDM network, and then we have an IP over the DWDM network. We want to provide, for example, hard slicing in the sense that we are creating new virtual IP devices per slice, and then we are, for example, providing different disjoint paths with the optical resources. Thus, we are providing this hard isolation between the different proposed slices. So let's talk now a little bit about the network slice data model that we are using as the northbound interface of our network slice controller. It is currently under definition at the IETF, And basically you can observe that it extends the network topological model. You can see here in the right side how it augments both the network node type, the nodes and the links, and also it includes a new network slice tree on the data. That's how it is augmented from the topological data model. It also imports traffic engineering topology information. So you can see that there are available the OTN, the layer 2, layer 3, the topological models, and now it is being worked on the network slice model. So that's the intention of the people who are working on the draft, and we have used this draft in fact because it allows us to describe these isolation levels that I have previously presented. Also, as I was explaining, we are using the ONF Transport API for the interfacing with the optical SDN controller. That's being defined by ONF. It's currently clear. There is an implementation agreement on the release 2.1.3. That's something that is stable, and we have been using for describing this hard slicing the feature of diversity exclusion. This feature allows to include a set of connectivity services which you want the connectivity service requested to be a disjoint path. So in this way, this feature provides this hard isolation that we were looking for. You can see here on the right side how the tree of the Transport API looks like, and you can see that this is the list that of connectivity services you want to exclude the path, to have a disjoint path. In this slide, we can observe the MAST SVI telephonic API SVI specification that focuses on OpenConfig for layer 2 or layer 3 VPNs. And this is between the SDN domain controller, the IP controller, and the virtual routers. So that's also another of the interfaces that we are using in our demonstration and in this paper. So we have the several steps. So first we need to create a VPN, then we need to configure the VPN access interfaces, then we bind these access interfaces to the created VPN, and finally we add extra configuration to the VPN, such as curative service or traffic engineering. This is the detailed workflow of our experimental validation. You can see that we are creating two different slices. First, we request the first slice, we request the network slice, we create the connectivity service at the optical layer. So this finally configures the ROADMs. Then we have a loop for this layer 3 VPNs that need to be created to support this slice, to generate the network instances, to configure the different interfaces, and we set up the interfaces to the different network instance, and finally we add the traffic engineering information for this slice. That's the first slice, and then the second slice with hard isolation that we are requesting. It can be observed that we are using a new instance of the virtual routers, and we are also creating a connectivity service request, which includes the diversity exclusion. So we have the first UUID of the first connectivity service, which we include as a diversity exclusion in order to have a disjoint path for this as a hard slice. This is so that, and then we proceed to configure the different virtual routers that we have generated for this second slice. So this is the experimental validation scenario. As you can see, we have been using an optical controller at CATC, and we have been using Volta Networks equipment that was available on Telefonica Labs premises in Madrid. For the interconnection, we had VPN between Telefonica Labs and CDTC. In this figure, and on the right side, you can observe an example of network slice request. You can observe that we are including the nodes and the links information. This refers to the layer 3 VPN that we want to configure between the virtual routers, as well as we provide the isolation level, both for the nodes. In this case, we request for physical memory isolation, than for the network, which we request physical network isolation. These triggers, as I explained, this joint path request for the optical layer. And in this slide, we observe the Wireshark of this deployment. So you can observe here the request, the network slice request. Then this triggers the connectivity service towards the IP layer, and then we observe how the virtual routers are created, and then the virtual routers are configured for this layer 3 VPN that is inside this requested network slice. So let's summarize the presentation. So we have seen a validation, an experimental validation of an end-to-end architecture, which allows this deployment of transport network slices with several degrees of isolation. So right now we have a clear architecture that allows to provide hard network slices and soft network slices. This is very valuable because it allows network operators to rely on the same infrastructure, but to offer new kinds of services which might provide different degrees of isolation. These results indicate that this feasibility of this deployed multi-layer IP over WDM transport network slices, which are based on virtual routers and optical disjoint path to provide hard isolation, and that soft isolation is instead reached through connectivity constraints and layer 2 service router configuration. These are the two ways that we have experimented and validated to offer these transport network slices. But it's very valuable to offer transport network slices which provide different features from the underlying technologies, so that we can also in the future think of, for example, transport network slices which make benefit of the time division multiplexing of optical networks, for example, in order to provide some deterministic latency, for example. So thank you very much for the attention. I recommend that this is a result of the TerraFlow project, so I encourage you to subscribe on our social media to get more information. Thank you very much, and goodbye.